guys, today we're talking about transformations. So earlier in a couple chapters we talked about congruence transformations. Now we're going to introduce similarity transformations and then verify similarity after a similarity transformation. Okay, so a couple vocabulary terms. Here we have a dilation, which is described as a transformation that enlarges or reduces the original figure proportionally. Then we have a similarity transformation, which is a transformation that produces similar figures. Center of dilation is a fixed point where the dilation is performed about. Okay, then we have a scale factor of a dilation, and that's often referred to as the variable k. So if we're talking about a scale, we might say k equals some number, and that's what the scale factor is. So that is the ratio of corresponding sides. Now, an enlargement is when the scale factor k is bigger than 1. It's like over 100%, okay? So it's getting bigger. Now, a reduction is when k is between 0 and 1, which would be like a decimal or a fraction, so it's getting smaller. And that's kind of what this page is talking about. We have types of dilations, enlargements here on the top, reductions here on the bottom. So we already talked about the numbers. Reduction is going to be between 0 and 1. Enlargement is bigger than 1. So over here in this diagram, we have this little blue triangle, and we're making it bigger to get that green triangle. And then on the bottom, we're starting with this, this blue shape and getting smaller to get that green shape. So we're just going to talk about this one. So we have to determine whether the dilation from figure A to figure B is an enlargement or a reduction. Then we find the scale factor of the dilation. Okay, well, going from A to B, it's getting smaller. So we're going to say that that's a reduction. Okay, now also we have to find what the scale factor is, okay? And that's the ratio of the sides. So I'm just going to look at this side. Okay, and since that's a straight line, I can count what the length is. So the length of that side of A is 4. And the length of this side of B is 2. Now there's kind of two different ratios here. We could have A over B, or we could have B over A. So let's just plug in the numbers and see what we get. So if we have A over B, we would have 4 over 2, which is 2. And then if we have B over A, we would have 2 over 4, which then simplifies down to 1/2. Now, since we're talking about a reduction, which one of these would make sense? This 1/2. Okay, so what that tells us is we have to take our new image over the original image to find out what the scale factor is. If we were going from B to A, then we would set it up as A over B because that would be growing. Okay, so like I said, our scale factor is 2/4 or 1/2. Which is what we did on that other page. Okay, so now we have to determine whether the dilation from figure A to figure B is an enlargement or a reduction. Let's do that first. So from A to B, looks like we're getting much bigger, so we're going to say that that's an enlargement. Okay, now we have to find the scale factor of the dilation. Let's just do the same thing that we did in the last one. Okay. A, we have this 1 as our side length, and for B, our side length is 3. Okay, and now since we're going from A to B, and B is our bigger one, we need B over A, which is 3 over 1. So our scale factor here is just going to be 3 because we're getting bigger, and that's bigger than 1. And there we go. Okay, pause your video, work this one out on a side piece of paper from your home. Okay, so as we've been doing, we're going to figure whether the dilation from figure A to figure B is an enlargement or a reduction. Okay, from A to B, looks like we're getting smaller, so we're going to say it's a reduction, so we know that it's not going to be C or D. Okay? And now we have to figure out if the scale factor is 1/2 or 1/3. Well, this bottom one of B looks like 1, And this bottom segment of A looks like it's going to be 3. So if we take B over A, that's going to give us 1/3, so option B. Okay, here's another one. We're going to do the same thing. So we're still going from figure A to figure B. All right, figure A is here, figure B is here, so it looks like we're getting a little bit smaller. So we're going to say it's a reduction. Okay, and now we have to take our scale factor. So I just keep looking at these side lengths. So here this side length of B is 2. This side length of A is 3. So when we take B over A, it gives us, that gives us A. So we have a reduction, and our scale factor, or K, is 2/3. Okay? All right, so here's like some real world situations. We got a photocopy of a receipt, and that is 1.5 inches wide and 4 inches long. It says, by what % should the receipt be enlarged so that its image is 2 times the original? Okay, we're going to stop there. So if we multiply something by 100%, that's just the same as 1, right? So if we wanted to double something, we would multiply it by 200%. Okay? So then it says, what will be the dimensions of the enlarged image? Well, if we're just doubling the size, we would double our width and double our length. So we're multiplying it by 200%. So we get the enlarged receipt will be 3 inches by 8 inches. Okay. Here's one for you guys to try at home really quickly. So we're enlarging a picture that is 4 inches by 7.5 inches. He wants to fit it perfectly in a frame that is 400% of the original size. What will the dimensions of the enlarged photo be? Okay, well, if we're increasing it by 400%, that means we're multiplying it by 4. So we're doubling it and then doubling it again. So if we have a 4 and 7.5, okay, we're going to multiply that by 4, multiply this by 4. So here we get 16, and here I think we're going to get 30. So we should have a 16 inches by 30 inches photo to fit that frame. Okay, so now we have to do a little bit of graphing, and this is where we're verifying the similarity. So we're going to graph the original figure and its dilated image, then verify that the dilation is a similarity transformation. Okay, we should be seeing, okay, here we go. So here's our original coordinates, and here's the dilated image. So like this is our A that we were starting with, and this is our B, okay? So we're going to sketch it, and we're going to graph it, just using different colors, looks like. So we're starting with this figure M and O, this triangle, and then our dilated image is DFG, okay? So we're starting with this big one, we're getting down to that smaller one, so it looks like this is going to be a reduction, okay? But we have to verify that it's a similarity transformation. So what that's saying is, yes, this blue triangle is bigger, and this green triangle is smaller, but are they similar triangles? Okay, so this is how we're going to solve it. We really like to use straight lines because we don't have to use the distance formula to find the distance between 2 points. So this M and N, OM, GD, and DF, those are all straight lines, and really nicely we could just find out what the lengths are. So on the next page we're going to do that. And then also, these are both right angles. So we know that this measure, or the angle M, is a right angle, and this angle D is a right angle. And we're going to use that in just a second. Okay, so on the next page, we're just finding out what the scale factors are for those two corresponding sides, this one and that one. Okay, and we're getting 1/3 and 1/3. So the proportions, the ratios of those are proportional. And since we find that the ratios are proportional and we have a similar angle in between those sides, then we can use that side angle side similarity to prove that the similarity after the dilation is true. Okay, I hope that was making sense. Okay, so here's another one. We're doing the same thing, so we're going to graph our points. Okay, so we have a little blue rectangle and a bigger green rectangle, and it looks like the blue rectangle is where we're starting. So we're enlarging this, okay? And this one is a lot easier to do than a triangle. We don't have the side angle side, any of those similarity theorems, okay? But this time, we can just kind of take a look at it and say, all right, since it's a rectangle, it has 4 right angles, so all of our angles are the same, okay? I'm going to talk about this, maybe I'll use blue first. Okay, so it looks like we have 1 unit on each of the left and right sides, and then we have 2 units on the top and the bottom. Okay? Then for this green one, we have 4 units on the top and bottom, and then 2 units on each of the sides. Now, to check the similarity, we would have to look at all those corresponding parts. So we would have, if we look at the left side, so we would have 1 over 2, or sorry, 2 over 1. Okay? And then this top, we had 4 over 2, which is equal to 1/2, or sorry, 2. My goodness. Miss Higgins, you're backwards. So here we have 2. This is 2. If we look at the right side, we have 2 over 1, which is 2. And then lastly, the bottom, we have 4 over 2, which is also 2. So the scale factor of all of these corresponding sides is 2, so we can verify that these shapes are congruent. Okay. All right, here's one for you guys to try at home. Okay, so on a side sheet of paper, you should graph this out, see if we're looking at a reduction or an enlargement. Okay, and then looks like we're having triangles, so you might be able to use a similarity theorem, and we should be finding that the scale factor is 1/3, and this is what your little graph should look like. Okay, I think we've got one more for you guys. Okay, so this time it actually gives you the graph, and we just have to verify. And this is the same exact one that we just did, it's just in a different position. So we know that if we're starting with this A, going to this, we're starting with this green or blue one for the original, and this is our dilated image, we know that the scale factor is 2. Okay, so another short lesson today, another really short assignment. We're just going to do page 514, 7 through 19 odd. Let us know if you have any issues with it. Good luck, guys.